Hi, Dr. Romano. Physics again?
Hi, I'd like to go over a question with you illustrating the concepts of work and power. Let's have a look. We have a 2-kilogram box that's being pulled along the horizontal, 50 degrees, and we have a 2,000 Newton force. And we're going to pull it 100 meters for 5 minutes. All right, easy enough scenario. What I want to do is two things. Let's first find the work done and the weight of the block. All right, the first thing I would do is let's draw a free body diagram to isolate all the forces on the block. We have the normal force going up, we got the weight, which is mg, going down, and of course the 2,000 Newton force at 50 degrees. Now, whenever we do work is equal to force times distance, but the force has to be parallel to the direction of motion. So if it's parallel to the direction of motion, we're on the horizontal. Therefore, we got to take the horizontal component of the 2,000 Newton force, which will be the 2,000 times the cosine of the 50 degrees. So there you have it. We have the work done is the force, which is 2,000. The distance is 100. And because it's adjacent, as you can see, to my angle, we're going to be using cosine. The exam will give you the cosine of 50 degrees, so don't worry about that. When we plug it in, we come up with 1.29 to the fifth joules. The weight of the block is easy. That's just simply mg. The mass is 2, the g is 9.8, and we get 19.6 newtons. Part B. Find for me the power. Now be careful of this because power can also be the rate at which work is being done. Well, we know power equals work divided by time, which if you remember, the work done was the force times the distance times the cosine of the angle over the time. Well, we already found the work. It was 1.29 to the fifth. We have 5 minutes. 5 minutes of time is 300 seconds. Dividing it out gives me 430 watts. Finally, derive the power unit called a watt. The way you would go about these type of questions is write the formulas that you know. Power is work over time. Work is force times distance over time. And we know that force equals ma. And then you got the distance and time. Now plug in. Power is in watts. Work is joules and time is seconds. So a watt is a joule second. Or force is newtons, distance meters, and time is seconds. So a watt, which is a joule per second, or a newton meter second, or if you plugged it into here, mass is in kilograms, acceleration is meters per second squared, distance is meters, time is seconds. Putting it together gives me a kilogram, meter squared, seconds cubed. Not memorizing, but as you can see, I wrote the formula out and I derived the unit looking at the formula. It looks like I've memorized, but the physics boys, we never like to memorize. You let the biology guys memorize. Physics guys analyze and understand.
Thank you, Dr. Romano. You made that very easy. Are you going to be doing any more physics?
I'll do some more very shortly. Good day to you.
Thanks, Dr. Romano. I love your work. Good day to you, sir.